All right, Bebe's kids, back at it today. Shout out to my friend Leo. We are going to talk about Hinge theorem and triangle inequalities. What's going on here? So we're just going to go through this kind of quick, but the first section here is just, is it a triangle? So we have these different situations. Are these numbers that would produce possible triangles? We're going to look at the first one. It says 5, 6, and 8. And I'm going to go to my friend GeoGebra, and I'm going to create a triangle with those lengths, 5, 6, and 8. So the first thing I'm going to do is a segment with a given length. I'm going to make the longest one 8. So that side has a length of 8. I'll prove it. Boom. The other sides are lengths 5 and 7, I think it was. 5, 6. So I'm going to make a circle with a radius of 6 and a circle with a radius of 5. And what we know is that anywhere on this circle, the length will be 6. And anywhere on the other circle, the length will be whatever it was, 5. So anywhere on this circle is 6 units from A, and anywhere on the other circle is 5 units from B. Could we make a triangle with these values? And the answer is yes, right? If I put those points right here, that spot is on both of those circles. And I'm not going to be able to get it perfect, but you guys get the idea. That location would make a triangle with lengths 5, 6, and 8. So the answer is yes, I could make a triangle with those three sizes. All right. So far, so good. How about 7, 11, and 3? Let's go in here, see what we can do. 7, 11, and 3. I want to make a segment with a given length. We're going to make it 11. Always do the biggest one first. The other two numbers were 7 and 3. So I'm going to go 7 from this side. I am going to go 3 from this side. And what do you guys think? Can we make a triangle with those values? Can we do it? Look at this point. Like that's even if it's straight on the line, are those going to reach each other? No. The answer is no. There's not enough there. Guys, like imagine that AB here, it's like a stick, and you're attaching string to both ends. From one end, it's length 7. From the other end, it's length 3. What is 7 plus 3? 7 plus 3 is 10. Well, how long is the stick? It's 11. They're not going to reach. They're not going to make a triangle. This answer is no. 7, 11, 3, not a triangle. How about 5, 5, 5? Let's go take a look at 5, 5, 5. So all three sides are the same length. They're all 5. So I'm going to make it 5. And then we're going to make circle with a 5. Ooh, with a 5. Ooh, that looks pretty cool. But the point is, this spot, that spot is 5, is 5 units from A and 5 units from B. Now I have a triangle with side lengths 5, 5, 5. So yes, can I make a triangle with side lengths 5, 5, 5? That is a big yes. One more, 7, 7, 14. What's your prediction? What do you think? 7, 7, 14. I'm going to make the biggest side first, 14. And then I'm going to do my circles. It was 7 and 7. Ugh. 7 and 7. Do they hit? And the answer is yes, they do. But where do they hit? Oh, goodness. What did I just do? I actually don't know what I just did. But where do they hit? They hit on the line. Think about having a rope of length 14. If you're 7 units from A and you're 7 units from B, are they going to touch? Yeah, they're going to touch. But they're not going to touch off the line. They're going to touch on the line. They're just long enough to touch. So that would not be a triangle. So what did we learn? The rule here is when you add two sides, it must be bigger than the third. That's the only way to get enough length. 7 plus 3, that's 10. Is 10 bigger than 11? No. They wouldn't reach each other. Over here, 7 plus 7. That equals 14. Is 14 bigger than 14? No. They touch, but on the line, not a triangle. But look over here, 5 plus 6, that equals 11. Is 11 bigger than 8? Yes. So they have some slack there. They have some space where they can touch off the line and make a triangle. 5 plus 5 is 10. Is 10 bigger than 5? Yes. So that's how we know if something's a triangle. All right, well, how about determining a third side? So if you know all three sides, that's the easiest situation. You can just take the two smallest ones and add them up. But if you don't know all three sides, you don't know which one's the smallest. So I'm going to call the third side x. Here is what we know. We know that 5 plus 12 has to be more than x. We know that 5 plus x has to be more than 12. And we know that 12 plus x has to be more than 5. Well, considering it's a triangle, one of these is true no matter what x is. And that's this last one, right? I don't care if x is 1, 2, 3.1, because we know x has to be positive. Otherwise, it's not a side of a triangle, because we're talking about sides of triangles. So we know it's positive. So 12 plus a positive number will be more than 5. So let's focus on the first one. 5 plus 12, that would be 17. So we know that x has to be less than 17. How about over here? Subtract 5 from both sides. X must be more than 7. So we get x must be more than 7, but less than 17. And just look at the two sides. Let's say it is 17. Let's say that this was 17. What is 5 plus 12? That's exactly 17. That's not enough room. That wouldn't get it done. That wouldn't get it done. But what if it was 16? Well, 5 plus 12 is 17. Is that enough where you have enough room to reach? Yeah. Yes. One of the big common mistakes people think, by the way, is if I say less than 17, does that automatically mean 16? No. Could it be 16.9999999? Is that, yeah. 5 plus 12 is 17. Is 17 greater than 6? Yeah. It'd be very obtuse. You'd have to zoom way in to see it, but it's doable. On the other end, we have to be more than 7, right? We can't just be less than 17 forever. For instance, like let's say you just said less than 17. Well, is 3 less than 17? Yeah. But is that a triangle? 5 plus 3 is 8. Is 8 more than 12? No. No. So 3 could not be that side, guys. It has to be a number more than 7. Could it be 7.1? Yeah. 5 plus 7.1, that's 12.1. That would work. That's fine. So this is my range of values. More than 7. That could be 7.0001. But it has to be more than 7. It has to be less than 17. So what's the fast way? How can you go from 12 and 5 to these numbers quickly so that you don't have to do all this work? Let's go see. So all you have to actually do is subtract and add, and you'll get those numbers. And that is basically what we end up doing there. We added and subtracted. Yeah. This is the lower limit or the lower boundary. This is the upper limit or the upper boundary. We approach them, but we never touch them. So we can't be 28 and we can't be 12, but we can be any value in between 28 and 12. So you add to get the high end, you subtract to get the low end. That's all you got to know there. Oh, there we go. 2022 softball champs, let's go. All right. Challenge question. What if you don't know any sides? So we went from knowing all three sides, so we just had to confirm whether the two smallest ones added up to a number bigger than the third one. We had two sides to get a range of values. We knew that the third side had to be between two certain numbers to fit the requirements. But what about if you don't know any sides? You have to do every possible situation. We don't know which one's the biggest. So first thing we're going to do is pretend x plus 10 is the biggest. So that means that 5x plus 5 plus 7x minus 2 must be more than x plus 10. We know that when you add any two sides, it has to be more than the third one. So we solve this. we get 12x plus 3 has to be greater than x plus 10. So we get 11x is greater than 7. So x must be greater than 7 over 11. So if x plus 10 is the biggest one, x must be bigger than 7 over 11. If you plug in 7 over 11, then these numbers would be equal. 7 over 11 is the number that makes them equal. If you plug in a number less than 7 over 11, it won't work. For instance, a real easy number would be 0. What if I plug in 0? This would be 0 plus 5 plus 0 minus 2. That would be 3. This would be 0 plus 10. This would be 10. Is 3 bigger than 10? No. When you plug in 0, it doesn't work. Less than 7/11 won't work. It breaks this situation. So we have to be more than 7 over 11. That's not negotiable. One way I kind of picture it is, what if you are someone who jumps through things? I don't know. So we got this. What if we have this bar that is at 7 over 11, right? And you're x. And you're like, do, and you have to clear the bar. You have to be higher than that bar. You got to go over that bar. You have to be a number more than 7/11. You could be 1, you could be 2, but you got to be more. To make it over the bar, you have to clear it, okay? All right, I know you see that. I know you get that. So let's go to the next situation. Let's say 7x minus 2 is the biggest one. Well, if that's the biggest one, then 5x plus 5 plus x plus 10 has to be bigger than 7x minus 2. So 6x plus 15 has to be bigger than 7x minus 2. That means that x has to be less than 17. Okay, so x has to be less than 17. If I plug in 20, it breaks this situation. If I plug in 17.1, it's no good. If I plug in 17, they're equal, and they can't be equal. So x has to be less than 17. So if we go over here, now we have a bar at 17. Well, we have to go under it. X has to be less than that. So what has to happen right now? In order to miss all the bars, we have to be under 17, but above 7 over 11. Woo! If we go too much, if we hit 17, we break the red situation. If we hit 7 over 11, we break the blue situation. That's a beautiful 7. All right. All right. Well, we'd have a third situation to consider. And that is 5x plus 5 being the biggest side. Okay, well, what if that's the biggest side? You would have 7x minus 2 plus x plus 10 has to be greater than 5x plus 5. So this would be 8x plus 8 has to be greater than 5x plus 5. So 3x has to be greater than negative 3. X has to be greater than negative 1. All right. All right. So now we have another bar at negative 1. Okay, what if I jump over negative 1? Is jumping over negative 1 a guarantee I've jumped over 7/11? Like the number 0. Isn't 0 bigger than negative 1? Yeah, but what happened? We plugged in 0 earlier. Didn't 0 break when we plugged it in there? So 0 can't be one of our answers. It can't be 0. So is it good enough to just jump over negative 1? No, I gotta jump over 7/11. Here's the good news. If you clear the blue bar, aren't you automatically clearing the green one? So if I have to be more than negative 1 and I have to be more than 7 over 11, ultimately just this one has to be true because it covers both things. And the big deal here is, guys, all three of these must be true. They have to all be true. Not one of them true, not two of them true, all of them true. So the statement that would make all of these true would be this. Because if I'm bigger than 7/11, I'm automatically bigger than negative 1. Guys, if you put negative 1 here, is this true for all of them? No. I could pick, like I said, the number 0. Now, the number 0 is in this range, but the number 0 breaks blue. And if it breaks any of them, it's out. So it cannot be that. No, no, no. It's got to be 7 over 11. All right. Ooh, that's me winning the playoffs last night. Nice. All right, Hinge theorem. So this is a new one. Hinge theorem, let's go. So what is Hinge theorem? It's hinge like on a door, right? We think of doors when we think of a hinge. So on this situation, we have our door, we have our doorway. That's like the 6 and the 10. They don't change size. The 6 and the 10 are locked in. They are not going to change. But the hinge, angle A, this is the hinge, angle A. As the hinge gets wider, what happens? Well, the third side has to get bigger. The 6 and the 10 don't change, but doesn't that third side get bigger? As the hinge gets smaller, right? As that angle gets real small, doesn't the third side get smaller? The answer is yes. So this is it. This is Hinge theorem at its core. If you have two sides, okay, so let's look here. So if you have two sides that match, got it. The bigger included angle, 50, has to produce a bigger third side. The wider it is, the bigger it's going to be. Now, this is only possible if you have two sides that match. You can't base it just on angles. With nothing, if you have no information on sides, you can't make any comparisons. But we know for sure on this problem that 10 has to be bigger than 40. So what we're looking for Hinge theorem is we're looking for an SAS situation. But not the same SAS. So the sides, they need to match. Boom, 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 boom. But the A, not equal. Because if this was 50, well, then they're just the same triangle. That's SAS. That's congruency. Now we know X equals 10. We're not looking for congruent triangles right now. So we're looking for an SAS situation where the sides are locked in, but the angle is not locked in. And the bigger the angle that's included, the bigger the third side. So we know that on this one, X must be less than 10. 50 is wider than 40. If I go over here, if I make the included angle 50, right, that's about 50, that's 7.68. If I make the included angle 40, that's 6.64. The smaller the included angle, the smaller the third side. That's assuming that two sides are locked in. Those two sides have to be the same. All right, so that's the first part of Hinge theorem. And a lot of people have no problem with that. They get that down after a little bit of practice. Here's the deal, though. Can we just be less than 10 forever? No. Could this be negative 10? No. Could it be negative 1? No. What is the deal here? We have to consider a lower limit. So if I know that X is less than 10, right? Like if I'm on a number line and I got 10, I know that I am less than that number. So I'm not 10, but I'm something smaller than 10. 10 is the biggest number there. But can I just be less than 10 forever? No. Eventually you cross this 0 line. And if X is 0, then this doesn't exist. So we have to also be more than 0. And it's not X that has to be more than 0, it's the side that has to be more than 0. It just so happens the side is X. That won't always be the case. So do you have a natural lower boundary? Yes, sides must exist. And in order for a side to exist, it must be more than 0. So we took X and made it more than 0. Let's look at the next one here. I flipped the 40 and the 50. So now X is more than 10. And that's actually our final answer. Why is that? Well, there's no upper boundary for side lengths, no natural one. Yes, there's some work we could possibly do if we knew some higher level math to find some sort of upper boundary, but that's not what we're doing. So for our intents and purposes, side lengths have no natural upper boundary. So that's all we're done with this one. Now, if I knew that this was 6 and this was 4, what would be the upper boundary if the sides were 6 and 4? Well, think about what we were doing earlier. If I gave you sides of 6 and 4, doesn't our third side have to be between 2 and 10? Well, that means now there's an upper boundary of 10. Right? Yeah. That actually doesn't make much sense. Sorry, because we know this is 10. That was not a good example there, because we knew that other 10. I'm so sorry. I don't want to confuse you too much. I'll show you that again on a different problem. But actually it'd be 16. I'm sorry, because it'd be 10 and 6. Nope. This is not good. Sorry for not thinking this through. On this triangle, I don't like it. I'm going to do a different example later. I don't like it. Undo. Sorry about that. Forget everything I said for the last minute. Let's go back to this. I'll tell you more later about what I was trying to do. All right. This is more in lines with what I was trying to do earlier. All right. So I got these two triangles. I got 40 degrees. I got 50 degrees. What do I know? I know that the smaller one is across from the smaller angle. So x plus 15 must be smaller than 4x minus 12. That has to be true. So let's solve that real quick. We know that 3x has to be more than 27. So x has to be more than 9. So is 9 my upper boundary or my lower boundary? Well, if I was on a number line and I got 9, what's going on here? I'm greater than 9. That means I'm bigger than 9. That means 9 is the smallest number. So right now we have a lower boundary. Is there an upper boundary? The answer is no. There's no natural upper boundary for sides. What I was trying to tell you a second ago, though, and it was kind of messed up because we already had that 10 and I wasn't thinking real clearly. But let's say that we know these two sides are like 10 and 32. I'm just making something up. If those are 10 and 32, forget this problem. If I said, hey, I got a triangle of sides 10 and 32, wouldn't the third side have to be between 22 and 42? Right? Just based off that, we learned this a little bit ago. So then, wouldn't the upper boundary be 42? And we would have to do some work to find that upper boundary. Okay, and I'm going to give you an example like that in a minute, so don't sweat it if you didn't understand that. We're going to do it again. But if we had side lengths, we would have an upper boundary, but we don't, so we don't. Let's look at this problem. Now, x plus 15 has to be less than 4x minus 12. Why? Nope, I got that backwards. X plus 15 has to be more than 4x minus 12. 50 degrees is more than 40 degrees. So the bigger included angle produces the bigger third side. So if I solve this one, I get 3x is less than 27. So x is less than 9. So what's 9 on this problem? Think about a number line. You got the number 9. Now we are less than. We're smaller. 9 is the biggest number. That's an upper boundary. We're looking for the lower boundary. There is a natural lower boundary. What is it? It is 0. If a side length is 0, it doesn't exist anymore. Okay, so let's say that we've got me. Boop. So, got my huge muscles, big smile, right? So there I am. And then we got, one of my friends. It's my son. We'll say it's William. That's my little guy. Now, we're saying x is less than 9. Can it be smaller than 9 forever? Well, as x goes to 8, 7, 6, 5, aren't the shapes shrinking? Aren't the sides getting smaller? And as they get smaller and smaller and smaller and smaller and smaller and smaller, who would disappear first? Who would be gone first? The answer is the shorter person. William would be gone first. I would be alive longer. If we were shrinking at the same rate, the smaller person would disappear first. Okay, why am I saying that? Well, If these two sides were getting smaller, who would disappear first? The smaller one. So this is tough. This is a lot of people are going to struggle. We will continue practicing it, so don't sweat it if you don't get it right away. But we know that 4x minus 12 is the smaller side, and we have to make sure that it is bigger than 0. In order to do that, x must be bigger than 3. Test it out. What is 4 times 3 minus 12? Well, it's 0. So when x equals 3, this side goes away. X can't be 3. Now at 3, this one's fine, but it doesn't matter. If one of them's gone, then this scenario's gone. So if it breaks any of them, it breaks the whole thing. So your job is to make sure that nothing is broken. So just to recap, why did I pick 4x minus 12 and not x plus 15? Because 4x minus 12 is smaller, and they are shrinking, right? If x is less than 9, aren't we going to keep plugging in numbers smaller and smaller and smaller? Well, we can't do that forever. Like, for instance, let's say you plug in 0. 4 times 0 minus 12. That's negative. It can't be 0. But even 0 is still okay over here. This one's going to be okay for a long time. The smaller one hits 0 first. That's why we made sure that the smaller one is bigger than 0. All right. Oh, this is the situation I was talking about a minute ago. So let's do it pretty quick, though. 40 is smaller than 50, so x plus 15 is smaller than 10. So x is smaller than negative 5. If I plug in negative 5, what is negative 5 plus 15? It's 10. We don't want it to be 10. They aren't equal. That can't be the case. It has to be smaller. So negative 5 doesn't work, but would like negative 4 work? No, sorry, negative 6. Negative 6 plus 15 is 9. That's okay. 9's smaller than 10. So we have to make sure that x is less than negative 5. Okay, so x is less than negative 5. Got it. Feeling good. Stop it. There we go. But can you just be smaller than negative 5 forever? So why is this one a challenge? Well, the natural lower boundary is 0. But we have a different lower boundary because of the 12 and the 7. Forget this problem. If I just gave you a 12 and a 7 and said, give me the restrictions on the third side, you would tell me that the third side is bigger than 5, but less than 17, right? You add to get the high end, 19. Who said 17? You add to get the high end, you subtract to get the low end. Well, we already have an upper boundary, so I'm not worried about that, right? If we're less than 10, we're already less than 19. And I should not have used x here because there's already an x in the problem. We'll call it y. I don't know. But we know that the sides have to be between 5 and 19. So I don't want to be bigger than 0. I want to be bigger than 5. So this is my answer. That is my answer. Woo! If we didn't know this, then we would have just said bigger than 0. But because we knew the 12 and the 7, we had to do better. All right, let's do some angle ones. I'm going to go real fast through this. Angles are a lot like sides, right? The bigger the side, the bigger the angle. So this is the bigger angle. So 5x minus 14. And by the way, it's a shared side. So is it a hinge theorem? Yes. We have two sides that match. The included angle produces the bigger included angle produces the bigger third side. So we know that 5x minus 14 has to be more than 2x plus 10. So that means that 3x has to be more than 24. X has to be more than 8. Think about a number line. We're at 8, and we are more than 8. So is 8 the top or the bottom? 8 is the bottom. It is the lowest. It is the smallest. So we need to think about an upper boundary. If it was a side, the upper boundary is limitless. But it's an angle. What is the biggest you can be an angle and still be inside of a triangle? And the answer is 180. So we have to consider the upper limit. Once again, which one would hit 180 first? So before we were shrinking and the short person would disappear first. But now we're growing, right? So let's say that we have a ceiling here and we're growing and we're growing. Who would hit the ceiling first? The taller person hits the ceiling first. So we have to make sure that the bigger angle, 5x minus 14, never hits the ceiling of 180. We know that 5x minus 14 is bigger, so as the angles get bigger and bigger and bigger, this one would hit 180 first. So x must be less than 194 over 5. So x has to be bigger than 8, but less than 194 fifths. Next situation, it's almost the exact same problem, but this time 5x minus 14 is less than 2x plus 10, right? It's across from 8 versus 10. 8 is smaller than 10, so 5x minus 14 is less than 2x plus 10. So 3x is less than 24, x is less than 8. Okay, think about a number line. We're less than 8. Now 8's the top. So we got an upper limit. We have to consider a lower limit. Well, if they're shrinking, which one hits 0 first? The smaller one. So we have to take the smaller angle and make sure that it never hits 0. And the number one wrong answer people put is they just put greater than 0. It's not x that has to be bigger than 0. It's the angle that has to be bigger than 0, which means x has to be bigger than 14 fifths. All right, list the sides in order from smallest to biggest. We've already done this a little bit. I'm just going to do this real quick. I'm not even going to go to GeoGebra. This last corner would be 20 because they have to add up to 180. Clearly not drawn to scale. That does not look 100. That does not look 20. Don't care. But remember that the biggest angle produces the biggest side. And the smallest angle produces the smallest side. I've showed you guys this before, but the smallest side would be AC. That's going to be less than BC, right? BC would be the middle. And that's going to be less than AB. That would be the biggest one. So keep that in mind. Within a single triangle, we can compare the sides based off the angles. We also can do the flip of that. If we know the sides, we can compare the angles. So that is smallest to biggest for that shape. Here, this is 60 degrees. This is 60 degrees. Does that mean that that's true? They're both 60. No. No, 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 no. It's not true. Why? Because we have no context for how big these triangles are. This one could be as big as the moon. This one could be as big as a spoon. We don't know how big they are. So this 60 could be, like I said, as big as the moon. This 60 could be as big as a spoon. Those are very different sizes. They're on completely different triangles. We have no way to compare them. So don't tell me stuff like that. If you see a 70 in one triangle and then a 70 in another triangle, that's meaningless. You have to have more information. If you have side links, like with Hinge theorem, that's different. Right? If they have matching sides, that's different. We have no information on the sides there. Here's another one. List the angles in order. This one's small to big. The smallest one would be A. That's going to be kind of confusing. I'm just going to write A. A is the smallest one. The middlest one would be C. And the biggest one would be B. And it's just the bigger the angle, the bigger the opposite side. Triangles only, but that's the rule. All right, and here's the last one real quick. I guarantee you have to do this on your test. 2 triangles, you got to have a plan. So here's the plan. You cannot compare triangles or sides from one triangle to sides to another, or angles from one to angles to another. You can't do it. But you can do it within a single triangle. So if that's 50 and 60, this corner would be 70 because the angles have to add up to 180. Just looking at the red triangle, let's go from big to small. What is the biggest side of red? It would be AD. Right? That's across from 70. What's the middlest side? DC. And what is the smallest side? AC. So that information must be true. The red triangle says this must be true. So then let's go look at the blue triangle. 80, 40, this would have to be 60. They got to add up to 180. So just looking at the blue triangle, act like the red one's not there. Look at just the blue. We're going big to small. What is the biggest side? AC, right? What is the middle side? AB. What is the smallest side? CB. So check it out. What's happening? We have an overlap. So that's the answer. They both use AC. We know from the red triangle that both of those are bigger than AC. We know from the blue triangle that both of these are smaller than AC. So overall, the two red sides are bigger than the two blue sides, with AC being in the middle. You're going to have a test question just like that. Good luck. Have fun. Love y'all.